All right, so good morning, everyone, and welcome. My name is Megan Blackmore, and I am a learning coordinator for the Invasive Species Council of BC. Invasive Species Council of BC is a collaborative-based organization committed to reducing the spread and impacts of non-native species within BC. I'm joining you today from Kamloops, where I am grateful to live, work, and play on the unceded traditional territory of the Secwepemc. Thank you for joining us today for this webinar, co-hosted by the Integrated Vegetation Management Association of BC and the ISCBC, entitled Managing New Plant Invasions, Riding the Wave of Atmospheric Rivers in BC and Alberta. This webinar is approved in BC and Alberta for 1 continuing education credit towards the pesticide applicator certification. To qualify for the credit, you must participate in the entire webinar, including the quiz at the end. The quiz link will be added to the chat box following the presentation, and you will be reminded again at that time to complete it. This webinar is being recorded and will be available on the ISCBC's Learning Center later this month. ISCBC and IVMA members will have free access to this recording, and everyone will have the opportunity to earn CEC credits if they just watch the entire recording and complete the quiz at the end. The link to ISCBC's Learning Center will be in the chat box. And so if you have any questions about the credits, you can reach out to Gwen Shrimpton at IVMA. All right. And so now if we go to the next slide, Anu. Now I'm sure you're all Zoom experts by now, but if you're experiencing any technical problems with Zoom, please use the chat box, and Anu will, who is our tech support, will be able to assist you. So everyone is muted. You should only be able to hear myself and the presenters. In Zoom, you have the option to select speaker view or gallery view at the top of your screen. We recommend that you use speaker view. And also, if you have a question during the presentation, please type it into the Q&A box at the bottom of your screen. We'll be taking time at the end of this presentation to answer any questions, but time permitting. If you see your preferred question already in the Q&A box, you can click the thumbs up button to upvote it. And it will bump it up the list. If we run out of time to address all of the questions, we will share the questions and answers by email later. And now at this point, I'm pleased to give a warm welcome to and introduction to Gwen Shrimpton, who is the Executive Director of the Integrated Vegetation Management Association. Please enjoy the webinar, and over to you, Gwen.
Thank you, Megan. This webinar is co-hosted by the Integrated Vegetation Management Association of BC and the Invasive Species Council of BC. The IVMA is a recognized organization dedicated to the responsible practice of vegetation management throughout the province. Our membership represents diverse industries, including forestry, gas and electrical utilities, railways and highways, and invasive plant management. The IVMA is the credit coordinator for the Ministry of Environment Continuing Education Program for the recertification of pesticide applicators for the forestry, industrial vegetation, including noxious weeds and aerial categories. You must be a member of the IVMA for us to track your credits. Information on this program, as well as how to become a member of IVMA, can be found on our website at ivma.com. We plan to enhance the opportunities for obtaining credits by holding webinars. This webinar qualifies for 1 credit in BC and 1 credit in Alberta. As Megan mentioned, you must provide us with your pesticide applicator certificate number when you registered for this webinar, and you must stay for the entire presentation, and you must answer the quiz at the end. You don't actually need to pass the quiz, but you do need to answer it in order to obtain your credit. And now it's my pleasure to introduce our speaker for today, David Clements. David is a plant ecologist based at Trinity Western University in Langley, BC. His research on invasive riparian plants, Garry Oak ecosystems, and climate change has yielded more than 80 scientific publications. He manages 3 of the Trinity Western University's field research sites, as well as teaching ecological courses on campus and field courses on Salt Spring Island and Hawaii. In 2022, he published 2 edited books. One is The Persistent Strategies of Weeds, and another book on global plant invasions. He is one of the editors of the New Biology Invasive Plant series on invasive plant science and management. He also edits a series on invasive species for Pacific Science, which he helped initiate in 2007. Finally, David is actively involved in local stewardship groups and writes the Green Beat column for the Langley Advance Times newspaper. Welcome, David.
All right. Thank you very much for the introduction. And now I'm just gonna, okay, share my screen. So I'm coming to you from the traditional unceded lands of the coastal Salish people. I'm in Langley here, but be presenting information from all over BC and Alberta. I don't claim to be as knowledgeable about Alberta, but do a lot of work here in British Columbia and with some of these co-authors here at UBC and Trinity Western University. So today we're talking about basically a lot about flooding, and we here experienced the November 2021 flood that was the costliest disaster in BC history. So I've got very interested in what happens on rivers like the river in the background here, which is the Chilliwack-Vedder River. So mostly so far, when people have tried to predict how much invasive species are going to move with climate change, they've looked at air temperature scenarios. So I have a big research question, which not really answered yet. How does this translate to aquatic systems, given the moderating effect of water? And in general, there's a lot of aquatic species that we don't know too much about. So a lot of what I'll be presenting today is questions like what more we need to know about these. And another thing we don't know much about really is extreme events like the floods of November 2021, flooding, storms, droughts, all these extreme events. And in that book that Gwen mentioned there that just came out last year, we had a chapter by Ziska, and he pointed out that, again, this is what we know and what we don't know. We know quite a bit about poleward spread of invasive species due to global warming, but there's also the effect of more carbon dioxide and the effect of extreme events he mentioned there. And when you look at extreme events, this is just American information, but probably translates fairly well for other parts of the world like Canada. These are the extreme events, and it's interesting, some of these do involve flooding and extreme storms. The green parts of the bars there are extreme storms. And when you add all these extreme events together, there's a definite trend. And I think we're all kind of aware of that trend from just watching the news, the number of extreme events. So I think it's really important to look at this from an invasive plant lens. So we have this phenomenon called atmospheric rivers, which are simply rivers of moisture carrying water from tropical areas towards the poles. And they aren't that unusual, like the terminology is kind of new, but we do get quite a few of them. But the big problem is when they're a big atmospheric river. And so then the scale becomes enormous, like this one point where it maybe sometimes as much as 25 Mississippi rivers. So in the atmosphere, you've got a huge amount of moisture. And with climate change, you get more atmospheric moisture at times. And this is what causes these extreme events like we talked about in November 2021. This is a scene, and this is a scene similar to when I went to work that day. The part of the road I went by was flooded and there was a car there. And this is a depiction of the atmospheric rivers that month. This is one of the rivers, and it really, it looks like a river. And so here you have this meteorological phenomena, and there has been research to show it's definitely linked to, it wouldn't have happened at this level without climate change. And you have huge rainfall, unprecedented rainfall that caused serious flooding. And this is our beautiful Fraser Valley. amidst the flood, you could see all the farms there, and the Highway 1 was blocked, and it was a terrible natural disaster. But what I really want to get to is, how this affects the invasive plants. But likewise in Alberta, there have been extreme rainfall events too, and the Calgary floods of 2013 were a result of extreme rainfall on a melting snowpack in the spring. And so you have this combination of warming and rainfall that threatens our coastal areas here, where you've got snowpacks and a lot of water coming in very short period of time, like happened in Calgary in 2013. Very, very unexpected. No one really saw it coming. And it has human impacts. There's this town in Alberta where people are going to be forced out of their homes, supposedly by 2024, because the Red Deer River there is just getting too high, and the homes are too close. And similarly in Calgary, you had the Elbow and the Bow River flooding. So it comes down to these river systems. So now to really talk about how this affects invasive plants. At the bottom of this scheme here, you have climate dynamics. And let's see if I can get a pointer here. So the climate dynamics are what we just talked about, the extreme highs and lows, increasing temperatures, etc. And then you have the ecosystem itself, how resistant it is to invasion. Here we're talking about how invasions are influenced by climate. But then you also have the plants themselves. Are they plastic? Do they adapt? What's the nature of these plants? So most of my talk, I'm going to focus on this part, but when you look at the overall invasion, it depends on climate and how resistant the environment is. So first, I'm really going to focus on temperature, although these are all aquatic species, so flooding and extreme events also comes into it. So these 5 species we've looked at in terms of temperature, some in more depth than others. One species we're kind of surprised to even be looking at is water hyacinth, because you think of this as a tropical species, and it is. It's from Brazil, and it is one of the worst invasive species globally. But when you go to your local garden store, often water hyacinth is available. Like I've seen it here. And the thing that limits it in general are freezing water temperatures. And so when you look at this climatic picture for the whole world, and then you look up in our area, there's not much there in terms of habitat suitability, according to this paper by Kritikos and Brunei. And then if you apply a climate scenario going up to 2080 here, it does move north a little bit, but I think this map highlights the need for local research, and we've been doing that, working with Metro Vancouver and NSERC. And so this is a body of water in Surrey, which had an infestation of water hyacinth, that tropical plant we thought we'd never see here, and it actually overwintered 1 year. And then we went to see it, and we were excited, maybe we'll get to see water hyacinth, but it was gone because it had not survived the winter. So there are limitations to tropical plants, fortunately. So we did some modeling to see, could it survive in the Pacific Northwest? And so these are some of the details of the modeling, using bioclimatic variables and records for North America and an ensemble process. So there's several other species I'll be talking about where we use the same modeling approach. And then we use climate change scenarios to see, what could happen for water hyacinth in the future if it did get warmer and those overwintering conditions were less extreme. So in the current suitability, unlike that global map we saw, there is some suitable habitat for water hyacinth in the Pacific Northwest. And of course, we've seen it survive here. locally. But in the future scenario, it gets higher, but it's still a very coastal habitat, and especially around Seattle and Vancouver areas where you mostly be likely to expect it. And if you go to even higher scenario where we do less to prevent climate change, you get it somewhat worse. Another tropical species is water lettuce. And here I got to see it when I went to tropical China. You can see what it grows like here. It just looks like lettuce in the water. And it's interesting, McIsaac et al. Looked at the Great Lakes area of Ontario to see the winter survival of both water hyacinth and water lettuce. And water lettuce is less likely to survive cold winters according to its biology. So it has a higher minimum temperature. It just has to get to a certain temperature, 15 versus 11. So when we looked at suitability in the Pacific Northwest, again, it can survive here now, and in future scenarios, it could be more suitable. But again, it's in the Seattle, Vancouver areas, so not further inland. And you can see if we do less to prevent climate change, it's going to be worse. And when you look at its present distribution, it kind of makes sense as a tropical plant. It's found mostly in the southeastern US and very little on the western side. And of course, you can see the concern in the Great Lakes. So water lettuce is of somewhat less concern than water hyacinth. But then you have yellow floating heart. So you might come to a body of water and think, well, this is, the same kind of phenomena. But in this case, the species is native to Eurasia, the Mediterranean, so not the tropics. And it is able to overwinter as a dormant tuberous rhizome. So it can overwinter in freezing conditions, and can actually extend, could extend to the northern border of BC. So definitely a bigger concern. And this is another body of water in Surrey where we found it. This is a Biology of Canadian Weeds article from 2008 that gives a lot of good detail. So a lot of what I'm doing is pointing you to good information here. So this is yellow floating heart. It has some very interesting survival abilities, having these rhizomes and roots that can overwinter as pictured here. And in Ontario, where some of this research was done for this paper, you can see how it did overwinter, and of course we saw overwintering in Surrey. And when you look at the distribution then at 2008, you can see it's just getting into BC. So this is the distribution they mapped out for the Biology of Canadian Weeds article. And then when you look at it today, it's not, see, I don't think it's in Alberta yet, but you see in Vancouver, it's coming in. So here's this pond again in Surrey. And you can see it has much wider habitat suitability than those tropical species because it's from the Mediterranean. And there are a lot of infestations already we have to worry about, and it will get more and more suitable with time. Another species is parrot's feather, native to South America, spreading globally through the tropics. And it is sensitive to freezing, but still can overwinter. We've seen it overwinter in North England. And one thing to think about in aquatics is what happens with periodic flooding and the emptying of bodies of water. And this is one of many species that likes that fluctuating water level, which will come with extreme events. So you can see it does very well here in the Lower Mainland. This is the KC Slough in Pitt Meadows. You can see a large infestation of parrot feather and quite a few points here. And we went to visit where the ISCBC has been trying to control it in Richmond, and we're successful, but it was a large effort. So this this is definitely something to keep watching as the climate changes. And this is a study from Japan. We didn't actually model it here, but in Japan, you can see it's got some isolated occurrences in this Kanto region, but when they looked at habitat suitability, basically everywhere there was water in that region was suitable habitat. And we've seen it here, like I mentioned in Richmond, where it just can cause these sudden infestations. So parrot's feather is aquatic and emergent. Also, we have flowering rush, which also has this, it can grow as an emergent plant or submerged. And this is where the fluctuating water levels can be very important to understanding the success of an invasive plant or potential success. And it's interesting to compare all these plants because the earlier ones I talked about were liking close coastal conditions, but what we found with modeling the habitat suitability for flowering rush is that it prefers continental climates where you actually do have, a strong winter and warmer summer. And so when you look at the map of current suitability, there's some suitability in the coastal areas, but most of the suitability is further inland. And again, when you look at climate change scenarios, you do have some change with that, and actually even less suitable in the coastal areas as you look at these climate change scenarios. So where you really have to watch out for flowering rush is more inland areas in the BC and Alberta interior. And indeed, it has been found in Alberta and BC, and a persistent population here that ISCBC and the province is dealing with is Hatzick Lake. And here you see Becky Brown, BC invasive plant specialist, discussing flowering rush in this work here. So some of the species I've been mentioning, like water hyacinth, aren't here very much, but flowering rush has some persistent populations that we're dealing with. So to summarize these plants from increasing temperature scenarios, the tropical species could increase with warming temperatures, but really mostly limited to areas near coastal urban centers, whereas the habitat suitability of the more temperate species may actually decline in coastal areas to some extent. We don't always expect climate change to make it worse, but in the interior zones, plants like yellow floating heart and flowering rush could do better over time as the climate changes. So now we get to more focus on the extreme events, looking at these 6 species here. So again, I'm just going to point you to some useful information where you can do more in-depth look at these, but there is quite a bit of research coming out on some of these, and some are already here, and then others were just wondering, could they come and take advantage of changing climate? So Phragmites is a serious issue in Eastern Canada now. And as I mentioned before, the fluctuating water levels can be key to the success of these species. So what happens with Phragmites is when the wetland dries like this, or a riparian area, this increases the germination of the plant. So it almost needs these fluctuating temperatures to regenerate populations. And, you think, well, a storm, like that's going to hurt plants, and we see trees fall in storms. But for some of these invasive plants, a storm makes them stronger. So this is why after storms and flooding events, we need to monitor carefully. In one case, there was a hurricane force storm that resulted in a big increase in Phragmites. And so you can see it's very widely distributed. As I mentioned, problem in Eastern Ontario or Eastern Canada. And you also have native Phragmites. And the native Phragmites does better in more northern climates. So we really need to watch as the climate warms. Will the non-native one come And there's been some modeling done by Claude Lavoie's group in Quebec. And they found that there's a lot of areas in Quebec where it's already very suitable, but then the climate model they used showed increased vulnerability by 21 to 50% by 2050. And of course, part of that is the extreme events that would bring fluctuating water levels in these various lakes and bodies of water that they looked at. So this shows Phragmites, how scary it can look, 5.2 meters tall. So when I've gone back to Ontario, driving along the roads there, you see a lot of Phragmites. And here it has reached here, southern BC and parts of Alberta. So definitely something to watch. Another very large grass species is giant reed. And whenever you see this phrase, recruitment through rhizome fragments, this is a plant that's going to do well with flooding, because rhizome fragments can often survive well in water. And that enables them to move around. And in one case, they did a study in the Tijuana River Valley in California, and they were trying to manage the giant reed with bulldozers, but it made the problem worse because of these rhizomes getting broken up. And there is an upcoming paper, so I'm pointing you to information that's not even published yet, but this is in press. And this is this series that Gwen mentioned, the Biology of Invasive Plants series in the journal Invasive Plant Science and Management. And I'm very excited about this series. I'm co-editing with Darren Criticos in Australia. And it's a series designed to give you a very comprehensive view of a given invasive plant, like giant reed here, that's coming soon to the journal near you. So what the series gives you is not just the biology of the plant, but also its global movement. So where is it coming from? Where do we expect it to invade next? So Darren Criticos, who co-edits the series, is very good at mapping things climatically. So look for more of these articles in the future. I'm currently working on one on knotweed. So in the absence of that article at the moment, because it's not published yet, you can look at the range of giant reed, and you'll see there are some large populations in the southern US, but it's not nearly as present here in the north. It's not in the north like Phragmites. But one plant that is here is Himalayan balsam, and it contrasts in its biology to these other species we've looked at because it's an annual plant. But you can see it likes flooding. Its seeds get dispersed with flooding, and it's a very effective colonizer of disturbed riverbanks, as this study by Kuda et al. Found. Here you can see they compared areas that were flooded and were not flooded, and there's always higher populations of Impatiens glandulifera in those areas. So the flooding helps the plant spread, and it tends to be a riparian plant spreading on rivers. And it has this explosive seed dispersal in these seed capsules and grows right by the river. And this is a Biology of Canadian Weeds article we did in 2008 showing the different parts of Himalayan balsam. And if you look at the root system, like down here, it's not a very substantial root system. So often, you know, the question becomes, well, it's a nice looking plant, why should we get rid of it? But it actually makes rivers more prone to erosion because of its small root system and its annual life cycle. So this is a picture actually from Trinity Western where I work, showing where there was an infestation of Himalayan balsam, and then over winter it just goes to nothing, and then you can get high levels of erosion in those areas. And when we did the paper, this is the range, so lots in eastern Canada, some here, but notice how far north in BC had been found. The question is it still expanding its range in Canada, and could it expand with climate change? And indeed, from the present distribution, you've got more. There have been some efforts in my area to do some management on some of our rivers, but there's still a lot more that could be done. And it's interesting. This is a paper that just came out this year, 2023, by Canmaz et al. And these authors are based in Turkey, and they presented a model for Canada. So it shows, how we need to do more research in Canada, because they're warning us from Turkey that we could have a problem. And this is the current range, but in their model, it's kind of scary what they found over this simulation using the program MaxEnt, that there's potential for a lot more expansion of Impatiens glandulifera according to the model and climate change scenarios. Alberta just, if we go back here, Alberta is just getting it now, didn't have it back in 2008, but it's forecasted to be a large issue in Alberta and BC if we don't do much. As I said, we've done some control efforts here locally, but if we have more extreme events, flooding that spreads the seeds, then we're in trouble. So tamarix is a southwestern invasive plant. And one interesting study found that when it was flooded, like rivers flooded, at first the plant had difficulty with its physiology, but then it adapted over time. So this is this adaptability element we need to look at. So after 3 weeks of flooded conditions, photosynthetic rates return to normal. So this is a plant that can survive flooding. And it has been found in Canada to a limited extent, even though it's most of its range is in southwestern US. So it's definitely a invasive shrub along riparian areas. And it is sold horticulturally, so something to watch out for. Another big horticultural plant is butterfly bush. So butterfly bush, true to its name, has been popular in the past, hopefully mostly in the past, for attracting butterflies, but it is very tolerant to flooding and thrives in riparian areas. This is a picture I took along the Chilliwack River, and here you have the huge flower inflorescences, and they can produce 40,000 seeds per inflorescence. And so that's one way it can spread in riparian areas, but it can also regenerate vegetatively from stem and root sections. So that's 3 different modes of regeneration that enables it to move along riparian areas. And there is a climax modeling study by Kritikos et al. That shows its current suitability, and then how it could increase a lot with climate change. And so another serious plant to watch out for. So looking here at its current versus the current here versus future, you can see it moves well up into our area in terms of suitability, much further north than it's present now. Of course, it's already fairly common in places like the Chilliwack River. So now finally get to the last species I'm going to talk about, which is knotweed species. So knotweeds have a lot of the properties we've already talked about. We just mentioned different modes of reproduction, but also there's rapid growth rates, as we see here, and they have a high affinity for water. So they have extensive underground rhizome networks. When you look at a knotweed plant, you really have to be thinking about its underground portion of it, but it can also disperse via seeds. When we first knew knotweed, we didn't have the Bohemian variety, which now predominates a lot in the Fraser Valley. So that means it can reproduce via seeds and rhizomes. And a lot of these aquatic plants, the issue is we have limited herbicide options near water, so makes it difficult to control. And sometimes we have to resort to challenging methods like injecting with herbicides. or this is another method we've looked at in my research, looking at wire mesh. And even just looking at these pictures of Vanessa's work here, you can see how challenging it is to try and keep the mesh in place. And then it does girdle the plants. So this is a herbicide-free technique that can be used. And what we found was it reduced the growth rate, but it did not eradicate the plant by any means. And it can also forage beyond the mesh because of this large underground part. So again, you look at the above ground part of knotweed, and it's already scary with the amount of shade it provides, which creates monoculture patches like this. But then you look underground, as my students unearthed a rhizome, just to see the huge length of this rhizome, just as one example of its underground capabilities. And as I mentioned, the Bohemian knotweed produces seeds, and the morphology of the seed is adapted for floating down rivers, and different seeds have different, so over time they could be selected for their floating properties. But regardless of the exact morphology, you have a sequence of events that happens that my student Maria has followed, where they sink for the first few days, but then once they germinate, they float and can be carried further downstream. And then they exhibit cotyledons and then exhibit true leaves. But the main point of all this is that's 28 days, that's 4 weeks they've been in the water, they're still living. So if they're brought up on shore by some kind of extreme flooding event, or just manage to reach the shore, then they can survive. And we've tested that as well by putting them in pots at different stages. And regardless of the previous conditions, there's a huge success rate there. So seeds can result in new knotweed infestations and can benefit from flooding. But a lot of the research done so far shows the rhizomes, of course, are even more effective. And here we have the Rivière Chaudière in Quebec, studied by Claude Lavoie and his colleagues there. And you can see the whole river is infested by different types of knotweed. And they managed to look at what was creating the spread. And really it was centered a lot in urban centers where there's disturbance, but also flooding was responsible for a lot of the spreading. And obviously we need to detect when these knotweed populations occur, but they said for the Chaudière River, it's too late. And they also recently studied another river here in Quebec, again, infested through a lot of its range. And this gets to, how we manage plants. Like the obvious human inclination is just to dig them up. But if the patch is too big, the plant is too big, like we saw the rhizomes, just you'll create more disturbance and you won't kill the plant. But in a recently flooded plant, like a recently arrived rhizome fragment, what they did was experiment with pulling out the more recent ones. And they found that's economically effective for the labor costs and everything, but only if it's a recent arrival and the population is relatively sparse, like this population down here. But for a dense population, it's just not economically feasible. So it's too late if you have too many. So as I mentioned, they travel by seeds, also by stem fragments, but rhizome fragments have been shown to be the most favorable. And this is what we were looking at this past summer, seeing how well they traveled. And we've also looked at what happens to the rhizomes in water. And what happens is they get better able to germinate and grow if they've been in the water for at least 15 days, as this research shows. And indeed, disturbance by extreme events seems to help the plant, as we saw in this case in Vermont with Tropical Storm Irene, where it was both the disturbance of the flooding and what people did afterwards to mitigate the flooding. Of course, you have a lot of engineering or flood damage control, where you're moving sediments around, and that's going to help the invasive plant. So what happened after the 100-year flood that we mentioned at the beginning, November 2021? There was this extreme rainfall from the atmospheric rivers, and I can remember being out in this rain. It was a lot of rain. And then looking at the Chilliwack-Vedder River afterwards, you can see the amount of debris that was created. The actual course of the river changed. So it's definitely an extreme event with a discharge of over 700 cubic meters. So in the following summer, we did a survey to see what happened due to this flooding. And you can see we found large patches like this that had been there obviously for a great period of time, but then also among the debris that had been spread by the flooding, you had new knotweed growing. So this shows the ability of the plant to adapt or to take advantage of these extreme events. So a lot of small knotweed plants growing on the shores of the river that must have come through the November flood or other recent flooding. It is a very fast moving river, able to carry these plants and the rhizomes very well. So this is the basic results of our work, showing the green triangles are the 2022 patches, and there's more than 3 times, there's about 5 times as many as was seen in 2019. And clearly, like some of these islands were actually changed or formed during the flooding. So there's a big, a lot of evidence showing that this is due to the extreme flood of November 2021. Another piece of evidence is that a huge majority of knotweed patches were very small, 20 centimeters, 40 centimeters. So they were just had come recently. So we're going to go back this summer and see if these patches have become larger patches. Another interesting phenomena is a lot of the plants were isolated from other knotweed patches. So 11% total had to have come from a recent spreading event because they're too far from an existing patch. Of course, you have knotweed spreading underground through rhizomes, but in this case, they're more than 10 meters from the nearest knotweed. So they had to have come in that recent flooding event. And we also looked at the sources of these infestations. I think that's what we always need to think about in management of aquatic invasive plants on rivers, is managing from upstream to downstream, because if you have an upstream population that keeps promoting the downstream populations, you're never going to get ahead of it. So there's quite a few tributaries of this river that we investigated. We looked at 10 different tributaries, and 6 of them had knotweed. And you can see some of them had some substantial patches. These are grouped by the size class of the patch. And then this is a summary of some of the environmental information we looked at for these different tributaries. And now we're getting to the ecosystem resilience idea here. If you have heavy shade and you have native vegetation growing well, there's not knotweed in those tributaries. And these had a little bit of knotweed, but then when we get to the heavily infested tributaries like Bellbrook, Ryder Creek, and these 2 unnamed streams where it got double asterisk, highly infested. Here you had a lot of disturbance, like they notice in Quebec, where there's a lot of disturbance or unshaded areas because knotweed doesn't do as well when in a shaded environment. So we have these tributaries contributing to the picture in the river. And it's very interesting. Look at the distribution of sizes in the river versus in the tributaries. So you had in the river, you have a huge concentration of small plants, and in the tributaries, it's the opposite pattern. So this shows we really need to do management in the tributaries, or else they're going to continue to feed this infestation. The tributaries also would be subject to flooding and movement of seeds and rhizomes. So this is one of the tributaries, Ryder Creek. You can see some of the large patches we found there. And can see here, just dwarfing 8 in there, and huge patches that are obviously source patches for further extremes. So to summarize here, there's many challenges coming from extreme conditions, which normally would kill plants and plants would not be able to survive. But these plants like knotweed and those large grasses and all the species I talked about just thrive under these extreme conditions. And this is looking at this invader fitness here, the plants that are able to adapt and survive under these extreme events. So in order to prevent that kind of part of the invasion, we need to work on more ecosystem resistance to try to make the ecosystem more invasion proof, while also, of course, monitoring. So we need to monitor aquatic sites, and often, you know, after in the face of these disasters, we just think, oh, what do we need to do to help with the road building or whatever else has been destroyed? But we need to monitor the flooding results in terms of invasive plants. But chemical control options are limited. But ultimately, if we can increase ecosystem resistance, we could help prevent these large-scale invasions. So I just want to finish by thanking my co-authors and my students that did a lot of this work. Emma did a lot of the modeling that I talked about there. And then I've worked a lot on knotweed with Jennifer Grenz. And of course, these are the students that did the survey. So thank you very much.
Okay, thank you so much, Dave, for that presentation. It was very interesting, very detailed. So we will begin the Q&A now. Please use the Q&A box at the bottom of your screen to enter any questions that you have. I think there's one in there already. And just so you know, we'll be posting a link into the chat in just a moment to access the quiz. It is now open, and you do have to fill out that quiz to get your CEC. And it'll be open for the remainder of the time. You can access that link anytime after it's been posted into the chat. So David, there's the Q&A box. Would you like to read them and answer yourself, or I can read them to you, whichever is easier?
Yeah, maybe if you read them, because if you can keep up with them better than me, maybe.
Sure, yeah. All right, so we have one from Audrey Faber. She says, thank you for this information and timely presentation. I noticed that most of the modeling maps are focused on southern BC and Washington. Have these been extended to regions north? For example, the fact that Seymour Lake, which is just outside Smithers, has had an ongoing issue with yellow floating heart. The site did not show on the map you had earlier in your presentation. These regions also have many problems with Himalayan balsam all across the Highway 16 corridor.
Yeah, so the basic answer is no. Our study was focused, as I mentioned, it was funded by Metro Vancouver. So we looked at the Pacific Northwest, but it's very interesting. I mean, I think the information from Smithers is a warning to us that we should not just think that these plants are going to infest the southern part of BC. It's interesting to hear about those ongoing problems. So the suitability maps, I don't think went that far that we did, but you could map it, and I'm sure it would show that for those species at least it would be suitable. And with Himalayan balsam, she mentioned that's it definitely can. In Europe, it's been found very far north.
Great, thanks. All right, so then we've got a question from Jillian Stewart. She says, which drainage ditch in South Surrey was that picture with the yellow floating heart located at? I live near the area now and was curious where it is.
Yeah, I might have to get back to you on that. Like, we did a whole tour of sites that day, and I don't remember the exact place it was, but I can get back to you on that.
We can send a follow-up email after this, and we can include that in there.
Yeah.
All right. We don't have any other questions in the Q&A right now. We'll just give a second for anyone who's typing out. And just a reminder again to everyone, there's that link in the chat now for completing the quiz for your CEC. Make sure that you complete that. All right, doesn't seem like there's any questions coming in, but if anyone has questions afterwards, you can always give us an email out and there'll be a follow-up email. And so thank you for joining us today. I hope you all enjoyed this presentation.
Yeah, and I'm definitely willing to answer any questions afterwards too. I guess they have information to get questions through, right?
Yeah, they can email through our info email, or I'll be sending a follow-up email with my email attached, replying to that. Then I'll be able to forward that along.
Great.
All right, have a great rest of your day, everyone. Lots of good praise in the chat. I don't know if you can see all those.
Nice to get the feedback.
Yeah, I thought it was a really great presentation and really interesting topic.